All right, welcome. So, in this particular class, in this session, we are going to be looking at data wrangling with pandas. So, in the last one, we looked at pandas fundamentals, how to create data frames from scratch, how to load data frames from CSV files, from Excel files, how to connect directly to a database and query um, that particular database and pass the output of that query into a pandas um, data frame. So in this particular one, we are going to be going into data wrangling with pandas. How do we actually wrangle data with pandas? So to get our data, we are going to go to Cargo. If you don't have Cargo, probably should sign up. It's easy to get data set from Cargo. So I'm going to go to Cargo and click on data sets. I'm going to look for some um, customer analytics practice data set. This is 3 kilobytes. I'm not sure about that. So what we're going to do is, well, as at the time that you might be running this, so you might not be getting this one. So let's particularly look for a data set. So let me look, just type insurance here, healthcare insurance. This, oh, that's too large. Insurance data 5 NB. Or let's do mall. I want something that, let's do supermarket. Maybe supermarket. So you type supermarket, this retail supermarket. Let's click on it and see what is there. Yeah, so I think this is beautiful. So it has 13 columns. And what we are going to do is click on this drop down here and click on select all, apply. So this drop down here, select or apply, then click on download so that it downloads the whole thing. So sample superstore.csv. So just save it and you should have it on your computer. So you probably should. If it downloads on your computer as a CSV file, as a zip file, you need to extract it. So let's move on. What I'm going to do after downloading, you must have downloaded, is let me remove this one from the previous session, delete file, and also delete file. Then I'm going to upload that particular one to session storage, and this is sample superstore. You're going to find it in your stuff, your computer. So once you load it, it's going to get loaded to your working environment. So while that is loading, let's just import pandas as PD for numpy as np, and that's everything that we need. So these are our data here, has been loaded. So I'm going to load data. I'm going to say store_df. It's going to be equals to pd.read csv, just like we saw in the last class, and sample superstore.csv is a store_df, and we can print out the whole thing. Yeah, so our data set is here and everything is working fine. Now, in our data wrangling step, we are going to be looking at a lot of different methods that helps us to wrangle data. So we are going to really be wrangling this data for about the next 30 minutes or so. So first thing we want to do is, this data has, about 10K, 9,994 rows. So we just don't want to like display everything, right? We just don't want to display everything. We probably just want to display a few. So what can we do in that case? We can use a method called .add. All right. So what I'm going to do is this. I'm going to remove this and run this. then show you .add method. So what do we use .add method to do? Add method. So if I do store underscore df dot add, so it prints by default, prints out the first 5 rows. If I pass in, let's say 2 dot add 2, prints first 2, which is 6, first 6 rows, so that we avoid print like just cluttering the entire space. So that is what dot add, but by default it prints 5 first row. And dot tail method is going to return store underscore df dot tail, and by default it does last 5. Can you see, from 999 to like all of this? Then the next method that we can look at is dot shape attribute. Shape is an attribute, not a method. So if I do store underscore, if you still do not know what the difference between method and attribute is, you probably should revisit object-oriented programming. So method causes the state of our class to change, causes our class to do something. Why um while um attributes just return characteristics, features. So store the shape, and usually you don't pass every time, you don't pass brackets to attributes because attributes are defined in the constructor. So just to churn out, print out something. So store underscore df dot shape. All right. So it tells us that we have 9,994 rows and 13 columns. The same thing that you saw during when we're doing NumPy. Then the next thing I want to look at is dot info. Dot info method. So what does dot info do for us? So dot info prints out some important information about our data set. The first thing you want to look at is the range index. We have 9994 entries spanning from 0 to 9993. Perfect. It means what this information tells you is that the index aligns with the number of rows. And you might be thinking, well, do you have situations where index will not align with the number of rows? Yes, we can. And those situations are situations where you have you've dropped some values. So if you drop some values and you don't reset your index, you have that kind of problem. We might see it today. So another thing to look at is the name of the columns and the data type of the columns. So you want to make sure that the data type of the columns is consistent with what you are seeing. So we see that majority of those things are consistent. Objects are strings, categorical variables, and the other ones are continuous variables. Continuous variables, floats, integers, and all of that. So that is what info returns for us. The next one is describe. Describe method, and describe method returns the a quick descriptive statistics of our data frame, and it is only going to focus on the continuous variables. So if I say store underscore df dot describe, we're gonna have this where, like I said, just the continuous variables, these guys here, these guys here. So however, you see postal code is also coming out, and postal code should not be, can you see postal code is integer, should not be a numeric variable. So we can change that. Let's just look at how to convert postal code from int to object. So how can we do that? We can say data, I'm sorry, store underscore df equals store underscore df dot as type. And actually we can convert just the one that we want to do. But then let's say as type, and inside this as type we can pass in like a what do you call it? A dictionary of what we want to actually convert. So if you check this doc here, you're going to see it. You're going to see it here. So um, something like this. So we can say column one, column two. This is the data frame, and we can do as type integer 32. So what we want to do is we want to come here and say the name of the column is postal code, postal code, and we want to turn that to object like so. Then if we check, if we run, let's run that. Then check store underscore df again, see what it looks like currently. Excuse me, that is wrong. Store underscore df. So we have our store underscore df, but let's actually check. Let's run this dot info again and see. It was what before. I'm actually not going to rerun this one. I'm just going to run it underneath what we've did here. What we've done here rather. So come here, run info again, and we see that postal code is now object. It is not integer anymore. So it does not have that additive property anymore. So if we come to this place and we run this dot describe, postal code is not going to be there anymore because it shouldn't even be there in the first place. So we use as type to change data types. So and you can use it to change multiple data types of a column. All right, so dot describe returns, descriptive statistics, mean, median, mode. This is median, standard deviation, first quartile, second quartile, minimum, maximum, stuff like that. Right. So the next one we are going to be looking at is drop. To be looking at drop method. So before we look at drop method, let's so that we don't drop too much of relevant columns. So let's look at how to create new columns. How to create new columns. So firstly, let's look at kind of columns that we can create. So let's create a column called um, net sales, right? So what is net sales going to be? Net sales is going to be this particular sales. I'm guessing this sales means the amount the person paid. So maybe this discount means let's check if this discount is greater than one. It is going to mean that it is not a percentage because I'm guessing it's a percentage. So let's go into the describe and check for discount. So discount is not up to one, right? So it means that discount is probably percentage. It's definitely percentage. So let's say we want to get something called discount value, like the value of the discount that was given. So how can we get that? So we can create a new column called discount value. Discount. Let's see. This is how you do it. You say sale. You call. What do we name this? Store underscore df. You call the name of the data frame first. Store underscore df. I'm gonna say discount underscore value is going to be because what I'm trying to do is this discount here is not an actual value. It is percentages because it's not greater than one, right? So we are going to come here because the max is 0.80. So we're going to come here and create a new discount value. So how do we do that? We're going to say that um, store underscore df of discount value. That's going to be multiplied by. So if we multiply it by um, no, this is going to be discount. The discount itself multiplied by store underscore df of sales. Yes, so what do I mean by that? What I mean is this: if we multiply 0.2 by 25, gives us what that person paid in discount. This one is going to be zero, which is basically what the person paid, which is zero. So once that is done, we can just call out store underscore df dot add to inspect what has happened. Perfect. So this right here is the discount value. So this person 0.0, they didn't pay anything. They didn't pay anything to this person paid 45% in this. This person got 45% in discount. So this is their discount value here. Great. So that's how you create a new column based on this is based on arithmetic operation. Based on arithmetic operation. So you can do addition, subtraction, multiplication, whatever thing you can do. So let's look at creating a new column based on conditionals. We create a new column based on conditionals. Conditionals, conditionals. Create based on conditionals. So how does that work? Let's say we want to see discounts that okay, we have profit and loss, right? Okay, that's perfect. So in this profit column, um, we see negatives there. So there are losses. So we just want to do profit loss break even. So anywhere we have positive, we have profit. Anywhere we have negative loss, then zero is going to be break even. So how do we do that? We're going to say store underscore df of profit remark, and we can come here and use something called list comprehension. So that's something you should also know by now. If you don't, you can go back to the fundamentals video and quickly check it out. So we're going to say profit if x is greater than zero. Now let's constrain it to the left. I can say loss if x is less than zero, else break even if x is equals zero. Then we can say else profit for x in store underscore df of profit. Store underscore df of profit. So that is how we do that. You can use your normal function to also do it, but I just find list comprehension easier to use. So if we come here now, we see profit, then we see just one loss so far. But we can actually check. So this is how you create based on conditionals. But we can check. We don't know now whether we even have a break even and all of that. So how do we actually filter rows? How do we filter rows? Let's say we want to filter rows. How can we do that? So filtering rows based on conditions. How can we do that? So the way to do that is, let's say we want to print out all of the profits, all of the rows that are profits. So I can say, I keep saying data, store df, use your square bracket, and we say store underscore df. Then I can pass in my the column that I want to use to filter. That's going to be profit remark column, and I can say equals. What is the condition that it is a loss? Let's check for loss first. Then if I run this, I see all of these outputs. They are all going to be losses. Loss. So I want to see for break even. That's how we know if we have break even. We do have break even. So break even, a lot of them actually, a few. a handful of them. We have a few break even. Then profit also. So you can also have multiple conditions. So let's say featuring rows based on multiple conditions. Let me put that here. Based on multiple conditions. Let's say what you want to see is you want to see, let's say I'm just going to copy this. Let's say you want, let me just type it from scratch. So let's say you want to see all of the losses that had discounts greater than 50%. That's a very stupid deal, right? So you say store DF and store DF again. Then in this case, we have multiple conditions. So it's not going to be just one. So it's going to be two. So we open a normal bracket and say store DF of profit remark. Excuse me. Profit remark. That is going to be equals loss. Then we can do and you don't do this and, you do ampersand, and we open another bracket. This should not be profile, it should be profit. So store underscore df, and this should be discount. And what we are saying is discount greater than or equals to 0.5. So if profit remark is loss and store underscore df discount, the discount that we give is more than 0.5, then that's a stupid deal. So let's see if they exist. They do exist, where we gave lots of discounts and we ran into a loss. This is crazy. So we ran into a loss, and yeah, that's how we filter. And if what you want to do is you want to get all, then you use this particular sign here, this straight line sign here. That's what we use for all, and is going to be this ampersand. Good. So next thing that we want to do is we want to see how to drop columns. So how do we drop columns and rows? Columns and rows. We use dot drop. So let's start with columns. Let's say we want to drop that profit remark columns that we created earlier, and we also want to drop the second one. I forgot the name for the second one. That is discount value. So how can we do that? You are going to say data dot drop. Ah, it's not data, it's store underscore df. I usually name all of my data. So store underscore df dot drop. Then if we are dropping columns, we must say columns equals, because dot drop actually by default works with rows. It's designed in a way that it works with rows really. So for columns, we say columns equals, then we list the name of the columns I want to drop. So what are those column names we want to drop? We want to drop profit remark, and we also want to drop discount value. And if I run this, it works, because now if you check, you can't find profit remark and discount value anymore. But hold on, if I just come here and run store df again, they are back. Look at it here. Profit discount value and profit remark are back. The reason is because we didn't pass in a variable called a parameter called in place. As the in place equals true. So passing in place equals true is you're saying that you want this thing to be permanent, like you want to make this permanent change. And once you run that, it is gone now. It is gone. And if you run this again, you can't find all of those guys anymore. They are totally gone. All right. So that's how you drop columns. How do we drop rows? So to drop rows, we are only going to drop temporarily. So we say dot drop also, and we're just going to pass in. Let's say I want to drop 0, 1, 2, 3. If I should do that, you're going to see that this thing now starts from 4. And if I want to drop the first 70 as a list, range 71, and now it starts from 71. It has dropped 1 to 70. So that's how you drop. But then I really do not want to drop. So I'm not going to, this is just a temporary drop. I'm not actually I'm going to do a permanent drop, right? So I'm going to say in place equals true. So if I run that now and say store underscore df again, what has happened is my index is starting from 71. What if I want to make it start from 1 again? I can do something called reset index, and we use it to reset index whenever we drop columns. So that's going to be store underscore df dot reset underscore index, and I have to pass in something called drop equals true, meaning that the previous index, this one that we are resetting, it should not be turned to a new column, it should be dropped permanently. Then I also want to pass in place equals true so that this thing is going to be permanent. Then once that is done, store underscore df dot add, and if I run that, this is going to start from 0 again, and it is still the same record of the 71st person. Can you see this Jackson, Michigan person? Jackson, Michigan person. All we have just done is reset index, right? So another one that we can look at is for checking missing values. How do we check missing values? We use is null. So we can say store underscore df dot is null. And if you do that, we're going to get all of these false, false, false thing or true. That is, if there is a missing value in that location, we're going to get false. If there is not, we're going to get true. So for us to actually get a cleaner output, we just say dot sum it up, and we see that there are no missing values anywhere. If there's a missing value somewhere, it's going to put 1 or 2 or 2 if you can find 2 there. So that's how we check missing values. So let's say we want to print out all of our column names. How do we do that? So to print column names, the way to do that is just store underscore df dot columns, and this happens, right? Ship mode, all of our columns. If we want to rename a column, we can say store underscore df dot rename. I'm not quite sure if you need to pass in the entire columns, but let's check. Let's say we only want to rename ship mode. I think the new name is the first one. I'm not sure. Ship mode should be, I mean, common sense wise, it should be the old one. I've used it, but every time it confuses me which one should go first. So the ship mode should be ship mode. I doubt that is going to be the way. Let's just do for only one column. Let's only change ship mode. So I'm going to add in place here. True. And we are going to run it. It works. So it's the old one, then the new. I'm not sure if it works because sometimes it runs, but does not work. Oh yeah, it worked. So ship mode has changed to ship underscore mode. So it is the old name first, then the new name follows it. That's how you rename a column. So how do we get the number of unique elements? Let's say we want to get the different number of segments of states that we have. How many unique states do we have? So we can do unique. So we can say store. Actually, before we do that, we have not talked on how to get how to access a single column. So how do we access a single column? Store underscore df like this, and we can just say state or anyone that you want. So can you see? Or you can do dot state. As an attribute state is the states. Oh, it's capital state. So that works. But you should not use this type because of situations where you have space in your, for example, postal code. If you do postal code, it is not going to work. Even though it's correct, it's not going to work because there is space. So, but if you use this style is always better because you can just wrap everything in quote and run it and it works. So that's why you should just make this style your default approach. So let's say we want to get our unique number of states. So I can just get out the states to begin with, and I can call the unique on that. So it returns the list of the unique states. So let's say I want to see the number of those states. So that is going to be dot n unique. So n unique is basically like just calling len number of unique. It's just like calling len on the output of unique. So we do n unique 49 states. So if you want to check the number of time, like number of customers in a particular um number of customers in a particular state. So how can we do that? You can do something called value counts. And that is basically the last thing that we're going to be doing before I show you the doc. So store df state dot value counts. If you do this, these are like all of the customers that we have in each state. So we have the most customers in California, then New York, then Texas, and all of that. So that is basically data wrangling, how to wrangle your data, do this, do that, flip it on this side, check this thing, check that thing. You can do some stats with descriptive, you can do some correlation with, if you want to do correlation. Let's say you want to check the correlation between what and what, you want to check correlation between quantity and profit. You can come here, get those two things out. First, you can say store underscore df um profit and what's that? Correlation between what and what? Profit and quantity and quantity. So we are getting out this whole thing, right? So let's now do dot cur. So this dot cur, then there are three methods that you can pass in. Either Pearson. Pearson is the default. Spearman and correlation. And it's going to return the correlation matrix. And we see that there is just 0.2342228. So there is very weak positive correlation between profit and quantity. And we can also do group by. I don't want to take too long, but let me quickly show you group by. There are a lot of things that you can learn from just looking at the documentation. So how do we group by? So let's say, let me quickly show you the full thing. Store df like this. So let's say we want to see number of, let's say we want to see the profits that we are making based on each state. I don't know. Let's do something else. Based on each region. No, based on each category of product. Let's do category. So we can do like this. Profit, comma, category. And if we run that, we get this. So we can actually group it. So we can do dot group by. And by, what are we grouping it by? We are grouping it by category and we can do our level of aggregation to be mean, to be sum, not average. We want to see total profit made by each category by sum. So if we do that, we have it here. Furniture has this total profit, office supplies has this total profit, and technology has this total profit. So that is group by. So there are a lot of things you can do. There are a lot of pandas methods. And if you come to pandas documentation, they have an extensive, just like NumPy, they have extensive detailed documentation that you can go through and understand how majority of their implementation works. And to be honest, you should really you know um you can also do some plotting in um pandas. So you see there are a lot of things for you to learn here. So that is that on pandas. And yeah, I'm gonna see you in the next one.